Today's session will be co-chaired by Mr. Diptendu Datta, Technology Lead Ideas TIH, and Mr. Somdeep Mukherjee, Software Engineer at Babel. So we look forward to an insightful and engaging discussion led by our esteemed speaker.
Thank
Diptendu
you,
sir?
Vinisha.
Yeah.
Welcome, interns. We hope that your internship is progressing properly and you're getting the inputs for which you joined this program in terms of, the classes that are going on and your upcoming project assignment. So we are working behind the scenes on your project assignments. Hopefully you will be able to see this list of projects pretty soon by a couple of days for section 1 and section 2 next week. So we are creating a list of fantastic projects for you to work on so that you can make use of the knowledge that you are gaining from these various classes that you're attending. Today's session titled LLM Fundamentals will be about getting some of your concepts cleared. So the objective of today's session is primarily to get across some fundamental concepts associated with what we are doing today using LLMs. So it's more on the point of trying to understand how to use LLMs basically and sort of the entire ecosystem. So let me start by saying that using LLMs have become very commonplace today, right? So if you compare, for example, you are using Microsoft Word every day, almost maybe, and various other tools like browsers. Do you really care how they work? You're just satisfied using a browser. Do you actually think how a browser connects to a website, downloads that HTML page, parses that page, creates a document object model, executes JavaScript? You don't think about all these things. So you take it as a black box. Similarly, say database systems. Many of you have had the opportunity of working with database systems, right? So we use database systems on a regular basis here at Ideas, and we use SQL like everybody else. So whenever a development team is using a database, most of the time it is about the application logic, how to create those SQL queries, how to structure them, what is the performance and all these things. Almost nobody thinks about how that SQL query is actually executed in the database backend, right? I mean, there are tools to understand how SQL works, which variety of SQL is better, explaining the queries and all that, but hardly people use that. Similarly, large language models have almost reached that stage. Why almost? I think it has reached that stage where most of us are using these LLMs or SLMs or whatever it is, small language models, without having to understand how it actually works. However, we always think that it helps to understand how a technology works, to know about its both potential as well as limitations. So today's session is from that point of view, is to try to get some concepts cleared. I mean, I often see people have either a very romantic view of LLMs or absolute ignorance about how they work. So we will try to address some of these issues, and hopefully by the end of this session, you will get a balanced view of what LLMs are and how to use them basically. So this is today's agenda. We'll start off with this very important point that all of us need to understand today. I've titled this as model versus system. So this is a major source of confusion uh, amongst the general population, and students are included in that population. So we will start off with that, and then we have some slides on language models, their histories, and some material on large language models. So that we are planning to cover within the first hour of this session. In the second hour of the session, you will get exposed to some tools. So we'll be using the Olama tool, which is the most popular one. So I suggest, in fact, I almost insist that all of you install Olama and experiment with LLMs. As you well know, this has been repeated thousands of times, that the best way to learn something is to experiment with it, since we are working on technical issues. So it's better that you have a tool which allows you to easily make use of various language models. Okay, so Olama is going to be that tool. And we'll also have a brief session on how to use the API from Python. So maybe not all of you would be interested in that, but we'll just give you some exposure of how to use the tools to programmatically interact with LLMs. So that would be the second part of today's session. Right. So this topic of model versus the system. So loosely speaking, we don't make a distinction between the two. When we say, a new model has come out, perhaps we do mean the model. And sometimes we say, that the system is working worse. And so some people were of the opinion that GPT-5 was less useful than the earlier versions of OpenAI's model. So they might be actually talking about the product. So basically, the model is just a massive collection of floating point numbers, and it is stored in memory or disk. I mean, its large models are stored in disk. Maybe they cannot be loaded into memory all at once. And there are various techniques for doing that. But the fact remains that this is a static object. It's not something, it's not code. It doesn't execute. A model doesn't execute. So many of you may be having that misconception that a model is actually some program, some huge program that executes. That is not the case. So the model, of course, is important, but in my opinion, and the way the industry is going, is that the system is more important than the model. So this may be an extreme point of view today, but as we move along, I mean, the distinction between various models would be difficult to make. So Gemini, this version versus Claude, that version, they will all be more or less the same. Think about databases, for example. I mean, even though some people would vouch for Postgres, I mean, there are others who are equally supportive of MySQL. What about SQL Server from Microsoft? So in many ways, there isn't much to differentiate between these. Similar things is happening in the LLM world. So the model, even though we always keep on thinking about the models, but what we actually interact with when you use something like, ChatGPT or Claude or whatever, is the system. So there is a distinction between the model and the system. And if I may share my extreme point of view with you, I think model is 10% important, system is 90% important. Again, this would not be agreed to by all, but the point I'm trying to stress here is that when you think of LLMs and the way you use LLMs, there is a difference. You think of LLMs as LLM is equal to model, basically. I mean, that is what the acronym stands for, large language model. But when you actually use something, you try to get something useful done with this model, it's this 90% system that is actually helping you. 90% in my personal opinion. But the fact remains that the system is very, very important. And if you look at the market today, I mean, this is how the market is shifting also. I mean, there used to be a time when model inference, even using the model. I mean, model inferencing is a technical term, maybe. Basically, you can think of you sort of ask a question and get an answer back or something like that, basically. So that was the raw model inference capabilities. Now, I mean, companies, whether it's OpenAI, whether it's Google, whether it's Claude, they are all moving from the raw model inference capabilities to something packaged like a consumer or business product. It is because that users are now more interested in using LLMs, so the raw inferencing capability of a model is less important. And in any case, as I was saying, all models are more or less becoming sort of the same in terms of their capabilities, whether they're multimodal, supporting video and image and all that. I mean, all models are sort of supporting all these multimodality, reasoning, and so many other attributes that you think of. So the unique selling proposition for these companies is the software part, the system part, basically. How is it packaged, and things like the reliability, the safety, whether there are legal compliance is being maintained by this product, and how it's actually useful for specific workflows. So, for example, Google has come out with that notebook LM for students and people who would like to sort of collect a lot of documents and then put them in some sort of a repository and ask questions about this repository. Okay, so mostly in the educational domain, that is the target. So if you think about the raw capabilities, I mean, this is a lot of value addition on top of the basic model. So this system is what is becoming more and more important today to the consumers. People think less about how the actual model is performing. They think more about how the system is performing and whether it is allowing you to make use of that model, basically. Okay, so in this model versus system categorization, let's focus on a bit on the model side. So here I have put up a table, and this lists some of the popular LLMs. You'll find included in that list towards the end is this open source version of OpenAI. Finally, after so many years, right? OpenAI has also come out with open source version of their models. So it's called OpenAI GPT OSS, and it comes in two varieties. And on the second column, you see things like number of parameters. Okay, and the third column is the disk size. I have put that in this table to remind you that, as we said earlier, models are files, or at least in most cases, it may be multiple files taken together. Like, for example, this 140 GB Llama 3.170 billion parameters model. So if you store it on disk, it would take around 140 GB. I mean, there are to arrive at that figure 140 GB, some assumptions have been made, and that is displayed towards the end of this lower part of this slide. That assuming that the model is loaded in half precision, floating point, etc. Some technical issues are there, but some assumptions are made to calculate how much disk space is required to store that model. And then the next one is basically, I think that the next one is not adding much value in the slide here. It's the memory required. I need to relook at that point. That is how much actually memory, if you would like to load that memory, the whole entire model into memory, obviously that would be the same as the disk size anyway. And the last column is very, very important for all of us today. It's the available file formats. See, when you talk about Microsoft Word files, it's docx. Excel files, it's XLX or XLS from the old versions. If it is a PDF document, the extension is or the type is the portable document format. So file formats are, of course, very important, whether it's your income tax. Of course, most of your students here in colleges, you don't file your income tax, but the government India has a format of XML files. At least that is to be the case for uploading it to their portal. So they used to provide some software that would generate that XML file. So the point I'm trying to make here is that next time you think about a model, whether it's Chat GPT or other, you think, what is the size of that model? You think about the file formats of the model. So OpenAI, for example, have come up with their own proprietary format. I mean, it's not proprietary; it's also open. It's called MXP4. Okay, MXFP4. I'm sorry. So the other formats that you can see here on the table, like ONNX, it was started by Microsoft, and then GGUF, this Llama CPP people, they popularized this, and of course PyTorch with and, the other libraries. These other organizations, they're using safe tensors and many other formats. So ultimately, a model is a file. I hope uh, that is sort of you're able to digest that. I mean, it's nothing. It's not code. Okay, it's not executable code. It's a ultimately it's a file, maybe a large file, maybe a small file if it is a small language model, but it has to be put on disks, loaded from the disk into memory, and then for various other operations on that, like the training that model requires a lot of CPU power, GPU power, a lot of electric power. You may have heard about that. But ultimately, when you get the model, it's a file. So that was the point I was trying to get across to you. Okay, now that we have some idea of the model side, let us take a little peek at the system side of the LLM ecosystem. So when you interact with something like ChatGPT or Claude or so many other tools today, what are these software modules that are actually working with you, for you, basically? Okay. So you have things like the input processing layer, and it has so many things that it does. Okay, like the tokenization. We'll be taking a look at little more details on some of these processes, perhaps in our next session, scheduled for next Thursday. But I mean, for the timing, it suffices to understand that it's a complicated and a large system. It's because this system is in place, you're able to make fruitful use of these models. The model by itself is not of much use. Okay. So it's because this system is here, like the input processing pipeline. It does things like context management. You may have heard that different models of different context sizes, and that the context size is increasing every day. Okay, so that the third point, safety filtering. This is becoming more and more and more important. I mean, there are cases of legal suits against OpenAI. I think I have that on the next slide or somewhere, where people are suing OpenAI because somebody committed suicide. So the questions that they asked, that needs to be filtered properly. So apart from
Sir,
bad language, and
sir,
abusive
sorry to
language, there are
interrupt.
many other
Vidisha,
issues that needs to be handled by this input processing pipeline. Okay.
sir,
Yes.
sir, Vidisha this side.
Yes.
Sir, one question is there in chat box. Will you take this now or will later on?
Yeah. Later, maybe. Okay.
Okay, okay, sir.
Right. So inference engine, for example. I mean, the question that was on the chat is important, but maybe we can get back to it a little later on. Yeah. So the inference engine. I mean, this is perhaps the most. I mean, the module that is most aligned with your mental model. When you think of models, perhaps you think of the inferencing side. The model has been created, it has been built by a team or a company after some hard work. Now the usage is done through the inference engine. So as I said, it's not just inference engine. Even before the inference is done, there are so many other things like, context management and safety filtering that requires it to be done. So the inference engine is very loaded, and the so-called forward pass is executed. That's the technical term for actually how the model generates its output. It's called the forward pass through the model, and then various sampling algorithms. And you may have heard about things like temperature and others that makes a model more deterministic or more creative. Many other things, the parameters that in some cases users are allowed to set. I mean, perhaps you cannot set the temperature when you are using ChatGPT, at least not in any simple way. So these parameters actually influence the sampling, the methods, and how the output token is selected based on these parameters. And then, if you must be having batch systems. I mean, the companies are working with batch systems. OpenAI, for example, has enterprise versions, and a lot of people have, in-prem system, that is, they are called. So they will be loading that within the company. They will not be using it on the internet. And so in many cases, these batch systems are there. The response generation orchestrator, that layer is that works on the decoding loop, basically. And then so many other aspects are there, like memory management. So I have put all these layers up here just to make you understand and appreciate that when you are using a LLM, all these software modules, I don't know what would be the size of the code, maybe millions of lines of code is actually executing. It's mind-boggling. You only think about the model, but all these things are actually executing, in combination through the orchestra, so that they are all sort of combining to give you the results that you expect from a good model. So it's just not the model. The goodness of the model is not good enough. No pun intended here. It's the entire system that has to be good and efficient for you to be satisfied with using an LLM system. Okay. And then you may have heard about things like function calling and web search. These are all getting integrated with the LLM systems. So previously we had that raw inferencing. I'm sorry. So you could just send some query and get the tokens back, but that is no longer the case. People have made an entire applications of so that you can call various functions, whether it's a calculator, whether some the backend APIs and things like that. You are able to search the web while your query is being answered. So what it does, it will actually go out and get the results of these functions or the web search result, and then put that result of the function calling or web search into the context. So there would be the system prompt, your own query, and the function calling result or the web search result. All these put together would be put in the context, and that would be sent to the forward pass, basically. So that's how it would work. Okay, so the tool integration layer is there today. And output processing is, of course, it has been important. A lot of people are aware of the fact that LLMs sometimes produce output which are not, how to say it, safe, or uh, liable to be misused. We have some examples up in the next slides, so I'll show you that. So output processing has been a very important thing from early on itself. Okay, so we have things like safety filtering. Again, just like the input safety filtering, we have output safety filtering. And you may have heard about streaming. So there are various ways in which the response may be sent back to the user who is asking the query. Okay, there are streaming options, and of course there are loggings and monitorings. How do you think OpenAI came to know that people are using less of the latest version 5? I mean, apart from social media, they were looking at the logs. Okay, so given the choice, how many people are going in for 4.1 or the other versions that are also available. So logging and monitoring is, of course, important in any software. So same thing with an LLM systems as well. Infrastructure management. This again, of course, is very important for any multi-user system. You don't get to see it. Think about, Facebook or Amazon. Millions of users are logging in and hitting that website. So it's not just a single website. You have load balancers, you have autoscalers, hyperscalers, and so many other uh, things. And so this infrastructure management is, of course, a major module here, basically. So all these various layers, the point is that all these softwares, which may run into millions of lines of code, is actually executing to make that LLM system useful to you. That was hopefully this message has gone across to you. It's not just the model, how good a model is, how many billions of parameters it may have, what the context size of that model may be. These days, we are having these large context size models. Gemini started this trend, and others are also following. So the model itself is important, but the LLM system is also more important, if not as important. So hopefully that message has gone to you. So this is just a pictorial representation of all those modules that I had mentioned. You start with this user interface and API endpoint. Many of you are using the desktop. For example, I use the desktop version of both Claude as well as ChatGPT. Okay, but for things like u.com or Find and many others, I use their websites. So user interface, API endpoints, applications would be using their APIs. So like if you are, today we'll be hopefully be demonstrating how to use a LLM model using an API. So you'll get an idea if, for those who are interested in the programming part, basically. Okay. And then you have API gateways and then input processing pipeline we mentioned, the safety features. Regarding safety, this was the case that I was referring to. There were two tragic cases. In one case, the parents have filed a wrongful death lawsuit, and the other one is related to harmful delusions from ChatGPT led to a reported murder suicide. Okay. So what they're doing is the company OpenAI is now trying to classify. They use classifiers. You have already gone through, or at least some of you have gone through this classification class. I think the section 1 people have understood what classification is as a machine learning approach, and section 2 people are already have some ideas, I think, or I think both sections need to understand the basics of machine learning. So we shared a document early on in the internship, which explains what these basic concepts of machine learning, like regression and classification and clustering, etc., are. So I'm bringing that point back here to just mention that the small classifiers are used by all systems now. For example, how would you understand whether a user's query is harmful? You just don't send any query straight to the forward pass of a model. Nobody does that. First, this input is analyzed. It's classified using some classifier. Okay, so you have learned about various algorithms of classification. So these systems use these small classifiers. By small, I mean compared to the size of the model. Okay, these classification models are much smaller. So they use this specialized model in the front, this input processing pipeline. Similarly, in the output processing services also, a lot of classifiers are used to understand whether the output is maybe used by the malicious user for malicious purposes. So OpenAI is sort of trying to use these classifiers and others to understand the nature of the query and the response, so that such incidents where people like teenagers are using these systems and leading towards crime or suicide or things like that. Okay, so that is so the entire system is important now, right? Maybe I'm reiterating the same point here, but the entire system is important to make that LLM ecosystem useful and safe and compliant with the legal framework, how to use that. Okay, so we are taking a step back here, basically. So language models are a old concept. Large language models are a new, I mean, that's the new concept, new kid on the block. Some people say language models are pretty old. So what is a language model? So you step back from large language models and think about language models. So every day we have been using language models. Language models, all of us have used, whether it's Gmail or any other things. You get these recommendations of words and things like that, right? So they all use language models behind the scene. So the example here is a sentence saying that the students opened their, and then the system is supposed to uh, sort of come back with suggestions. Should it be, what should be the next word? Okay, should it be books, notes? I constantly sort of gave these suggestions from Gmail. Okay, that's one application. And there are other applications as well, which give you the suggestions of what should be the next word. In fact, they are these days you get entire sentences suggested. Okay. So how is this working? So the basic technology has been there. This language model technology has been there for, I don't know, maybe 30 years. Okay. So now they have reached a point where they have become very useful, but it's nothing new. That is the point I'm trying to make here. That language models are nothing new. They have been around for quite some time. Okay, and we have been using it also. Maybe we didn't use the word language models when we use them, but they have been around for quite some time now. So how do you calculate this? I mean, how does the system, how does the software, okay, uh, sort of predict which would be the most useful? I mean, please remember that there can be no perfect answer, right? I mean, it depends on the context. When I'm typing, the students open there, and the system is suggesting books that may not be what I'm trying to write. Okay, so I might have something completely different in my mind. So, but still it would give you some suggestions. But what are the suggestions based on? So that's the probability that it computes basically. Okay? And then with the notion of n-grams. We'll come to n-grams in a minute. Just a slide that I put up to suggest that the history of language models is a very rich one. So we start with 1966 and this chatbot and other things, statistical language models and this word to wake. And these are, I mean, the points in this diagram, those circular points are about major events or major results that were achieved in the history. So you can see that, I mean, I was saying 30 years, it's much more than that. Okay. It's almost 50 years now that we are using language models. So BERT used to be a rage when the transformer paper, the famous academic paper from Google, I mean, it's a research, I would say, paper came out from Google regarding transformers in 2017. It was immediately followed by the BERT model. Okay? And then there has been endless streams of models by various companies, starting with Google and then OpenAI entered the game in say around 2021. Okay, and then so many others have now joined the race. Okay, but remember that point that I was trying to make earlier, that uh, it appears that there is not much difference in these various models. I mean, they're sort of converging in terms of their capabilities, in terms of their robustness or multimodality and other things. So less than models, it's more of the system that is becoming important. Okay. Yeah, so back to this issue of how does the software predict the next token. So this has been one of the earliest models, the n-gram language models. I have some URLs up there. I mean, once you look at the video and you go to these URLs, you'll be getting a more detailed understanding of these concepts. And do find some time to look up this n-gram site from Google. and you can type, any word, and it will give you a idea of how popular that word is in history. So I'm sure, forward pass is becoming more important today. It was only meaningful in games of maybe football and hockey earlier on. But now people are using forward pass and backward pass and so many other things in terms of in the world of AI, right? So if you go to that Google site and you type in the word, it will give you the sort of the statistics of how important that word was historically, whether the importance is now increasing or decreasing. Okay. So here we have this sentence. This is a sentence, and unigrams, or whether we split it into single words, and then you have bigrams and trigrams, and then uh, the way we calculate the probability of the word W1 occurring after W2 is just to calculate the count in the existing corpus. So there is this notion of corpus on which you train the model. It's like the same thing, the same concept that we have today also, right? I mean, the concepts of a corpus is very old. So this is the input in the training process. So when you train the model, and whenever you see the word W1 occurring after the W2, you keep account of that. And then during this so-called, forward pass, or when you actually have to make that inference, and then you sort of divide that with the count that was already kept for the word W2. So W1, W2, for example, in this example that we have, so this is, for example, in the bigram model. So this is taken as a bigram and a count. Wherever in that corpus this is followed by is, so the count of W2, W1, that is this and is, that is the word is followed, sorry, the word is followed by the word this, is kept in some data structure or maybe in a file somewhere. So you keep on adding to these counts as you go through the corpus, as you analyze each sentence in the corpus. The corpus may be consisting of books, newspaper articles or others, and you calculate these probabilities, you keep them ready, and when you actually get a sentence in the so-called runtime, when the actual that software is going to be used to predict something, you make this calculation. So if somebody has typed in W1, and then you want to find out whether W2 should be predicted, so you try find the count of W1, W2, and then see how many times W1 is there, and you divide that basically. So here is some a more numerical understandable example. Instead of W1, W2, we have these. So you can see the corpus on the left. So the corpus has 5 sentences. And so we are trying to find out, calculate the probability of the word like occurring after really. Okay. So we often have this phrase, you really like ice cream, or you really like football. So we're trying to find out if somebody is trying or written the word really, should we predict the word like? In this case, it so happens that we have, really like, really sorry, really appreciate only once in the entire corpus. In a real life corpus, that would not be the case. But here, all are equally probable. So we say that the probability is 0.33. So yes, if somebody has typed the word really, like, appreciate, and sorry are all possible candidates. I mean, there is no choice between them. Maybe the software will randomly pick one of these choices and throw it to you, or maybe all 3 would be thrown to you. So that's how you calculate in a very simplistic manner these n-gram probabilities. Even though this is a very simple technique, the concept lies at the very foundation of all these large and fancy models that you think about today. Something like this. You have to think about how the probability is calculated as a black box. Maybe some more advanced technique is there. But the fact remains that what you are calculating is the probability, basically. Okay. And based on that, I mean, it may not be something as simple as keeping a count of which word follows which from a corpus. It may be something more sophisticated. But at the end of the day, what you're calculating is the probability of something, some word, the word like, occurring after the word really when you type in the question to a tool like ChatGPT. So basically, that is what is happening. And of course, the modern ones are neural language models. So, I mean, we don't have the time to actually go through. Maybe for people who are interested, you can. So you've heard about deep learning. That is the next step from the classical algorithms or the methods that you have been exposed to or you are getting to learn, basically. Or maybe you have already been exposed to some of these machine learning models, whether it's random forest or gradient boosting or whatever. So the neural networks and others are supposed to be more advanced. Of course, neural networks are also quite old in the sense, I mean, this concept is nothing new. The problem was that the hardware didn't support this architecture. It was very difficult to actually implement something in a software program and run it on a machine because the hardware couldn't support such, if it was more than a few layers or something, if the number of neurons were more in that network. So realistically, it was not used. But once, the hardware side improved, neural networks have been used almost everywhere in all walks of life, whether it's medicine, whether it's engineering, everywhere you find the usage of neural networks. And no wonder that large language models are also making use of these neural networks deep underneath. So this the way the prediction is done, that this cat sat on, the next word should be mat. The probability is very high for mat. There could be so many other words, the probabilities would be lower. This thing is sort of calculated by the network. If you are interested in actually going through the details of the internals of this neural network, many of you may have heard about the term transformers. So that was what was suggested in that 2017 paper, something like that. And then there has been no looking back. Of course, today in 2025, you keep on reading in places like the Medium. The end of transformer is gone. Now we need some better techniques that would be more, computationally efficient than these transformer networks and other things. But as of today, that still remains the basic foundation block. So if you want to learn more about the internal workings of these special type of networks that are powering the large language models of today, you can just follow those two links that I've given. They're quite useful, it appears to me. So you can also go through them and try to understand a little deeper if you are interested in understanding the black box of these architectures of large language models. But as I said, the model is not only the important thing, you have to understand the entire ecosystem if you want to actually make use of a language model or a large language model. Yeah, so we are coming towards the end of this, the first hour. So I guess we'll spend some time on, clarifying your concepts on how LLMs are built, how they are trained, basically. So there are three types of training primarily. Okay, the most that you hear about is the so-called pre-training. This huge, humongous amount of text that are fed into this the training processes, and these run for months using millions of GPUs. So that is the vision, that is the view that you have of how these models are created. So you have this very, very, very large body of text, and then they are somehow fed to these algorithms, these training algorithms, and they run on powerful machines, not for days or weeks, but for months. And then out comes a model. So that's the very simple view of how models are created. But in reality, I mean, there are various other steps that are absolutely essential. Uh, so the second one is the supervised fine tuning. Okay. So the first one, the results in what is called the foundation model. And the input to the supervised fine tuning is this uh, foundation model. Okay. Remember that models means it's a collection of weights, as we said. So you generate this foundation model after training on this huge body of text, and then feed that to the supervised fine-tuning process. And this has been the game changer for quite some time now. This is where you give the model examples of what is uh, how to actually sort of generate the output. So you give it supervised means you give it both the input and the output, and then the system learns that transformer network or neural network learns that how to produce the answers. So just having that pre-training and the foundation model is absolutely of no use. It's the supervised fine-tuning that makes it actually usable to the public at large. Maybe for researchers, the foundation models are important. I mean, they need to understand the various intricacies of the model. But to make it actually useful, the public at large, you need supervised fine-tuning. So in supervised fine-tuning, what happens is you give the model both examples of both the input and the output. Remember, in pre-training, there is no output, there is just plain text. Okay. And the system learns the next token prediction, how to generate the next token from the previous tokens. So something like that n-gram model. So you can think it of a sophisticated n-gram model. Okay. But supervised fine-tuning is where it actually learns to become useful. And it doesn't happen automatically. A lot of effort is required to actually create these data sets. You're already exposed to the term now. Every day, I think you're getting exposed to the term data sets in your classes and various other inputs that you're getting. So yes, for supervised fine-tuning, creating that curated data set is of utmost importance. So the data set consists of questions and answers, so that when that is fed into the model training process, the model learns how to give proper answers. And finally, this was the sort of the actual moment when everybody's attention turned to large language models. Even with supervised fine tuning, it was sort of okay, models are useful, but it's nothing so great with this so-called, RLHF, reinforced learning with human feedback, where you actually put people, human beings, who rate the various responses. So for the same question, multiple responses are possible, and the model wouldn't know which one is the best one. So there are human beings who are sitting with the generated answers. Remember, these answers are generated after the second phase. So the model now is able to generate proper answers to various questions. But multiple answers are possible. So which one is better? Which one is safer? Which one is cannot be used by a malicious user? That is not, it's not possible to automatically determine that. So that is where this RLHF becomes important, reinforced learning with human feedback. So apparently this was discovered accidentally. I mean, the full history is not known to me, but when this was being tried, it appeared that the results were astonishing. Okay, and then that is when everybody's attention sort of turned to large language models. So when we think of training of LLMs, we most of the time have this vision of this pre-training, large bodies of text which are fed and the system somehow learns the next token prediction. But that is only a part of it. To really become useful for the various things that we are doing today, I mean, it's mind-boggling to think the kind of applications that are coming out based on large language models. And all that at least most of that is because of the second and third type of training that uh, each model undergoes. Okay, so and this the pre-training part has become mostly commoditized. I mean, not much secret is there. So it's sort of open source, you can say. A lot is known about this pre-training. But whenever this SFT and RLHF comes, each company has its own tricks of the trade. Okay, and they are trying to sort of make a distinction in terms of how they are approaching the second and third phase of this supervised fine tuning, how they are making it more, you know, efficient, so that the next version of the model comes out very soon after the previous one. So GPT-5 took, I don't know how much, about a year after GPT-4. So that time people are trying to bring down that interval so that, next models, better models can come out. And each company, at least the ones that have proprietary systems like ChatGPT and Claude and others, have their bag of tricks that they are using in these SFT and RLHF, basically. And finally, of course, you have these downstream applications. These are the ones in which many the business users are interested in. I mean, they are not writing poems or answering or responding to assignments. They have the bankers have their own requirements. Healthcare people have their own requirements. That is where further fine tuning and in context learning is happening on top of what the basic training and SFT and RLHF has produced. So that's the final part basically. So this is the entire chain of LLM training. It's not just the pre-training. So many other things needs to be done to make these models useful. So here we have sort of what to note from this slide is this massive amounts of text that happens that is used basically in the pre-training. So if you take a look at this data quality filter here on the left, it says that after filtering, only 1 to 3% of the original tokens are useful for training. So you might be knowing or you have heard that these people scrape the internet to collect large bodies of text. So where would you get the most text? Of course, from the internet. I mean, there are millions of sites. If you are able to automatically scrape those websites and put the text in some files, that would be a huge corpus. But it turns out that only 1 to 3% of the original tokens are useful because of various other reasons. Various reasons are there for that. So just a raw token is not good enough. Okay, I mean those you need to have a lot of quality control, and so there is a extensive process of quality checks that goes on before. For example, removal of harmful content, removal of abusive language. So if you let those pass through the filters, the models will actually learn and predict those tokens. Okay, that would be an embarrassment for the companies. Okay, so they take a lot of effort in filtering that raw data set so that only high quality, good quality and safe text is actually being fed to the model training process. And you can see the sizes of these uh, text corpuses that are used in the pre-training, 1.9 terabytes and 3.1 terabytes, and it's a huge, huge basically. Okay. And the Wikipedia has been kept there at the top left, sorry, bottom left, as a comparison. That you think of the Wikipedia as something very large, it's only 0.001 terabytes. Okay. And compared to that, you have just no comparison at all. Okay. GitHub itself is 3.1 terabytes. And there are various issues whether people should be using that and whether the private repositories, we have public repos and private repos in GitHub, right? So are the private repos are also being used in the model trainings? So we don't know for sure. So that's the scenario of the pre-training. So, I mean, I think we have come to the 8 o'clock timeline. So let me check whether uh, the whether Shomdeep is around, because he will take some time to sort of give you that hands-on part. Just let me check.
Okay. Oh, just put the window of the.
Yes,
So
sir.
Vidisha, can you please make can
Yeah,
share?
yeah, yeah. Yeah, he's unmuted.
Okay. So this is one animation that I put across. I mean, that J. Alamar is one of the peoples who have been working tirelessly, I think, trying to make this high tech available to all of us. Okay, so he has prepared so many visualizations. So this is one just such visualization. How this unsupervised pre-training is happening. Unsupervised is because, or self-supervised, because you don't create those uh, question answer pairs. Here you just give it the raw text. Of course, after this filtering, as I mentioned. So a lot of filtering happens, but eventually what goes into the pre-training is simple text. There is no distinction between questions and answers. Just so there is nothing called write a poem uh, and then somebody gives a poem. So that is not there basically. It's just maybe a poetry book is there, poems are there, essays are there, novels are there, so many programming books are there. So all these texts, or from the internet websites, all this content is going in. But how it's trained, this animation is trying to show something like that. You have this the correct output level expected is the obey. So remember that this sentence is already in the text. Nobody has created this level by hand. So there is some article or some novel somewhere where there is a sentence called a robot must obey. You may have read the Asimov books, or maybe you are too young for that. So, so there are laws of robotics, right? That a robot cannot harm the human beings and things like that. So this example is perhaps referring to one such book or some article on that. And the system is such that the training process has kept that token obey, or the word obey, aside, and it is trying to see whether the model is predicting the word obey or something else. For example, if it is predicting exterminate, it's just the opposite basically. So it is going back to the model training, saying that this is not the correct one. So self-supervised means these labels are not there created by hand. It's in the text corpus itself, and then there is a technique to hide that word and then make the model accurately predict that word that has been masked. So there are many techniques like masked language modeling, next token prediction, and so many other techniques there. Yeah, I'll just leave off before leaving off, I'll just give one or two examples that I had mentioned. So you can go to these links and go see the details. So suppose you are asking the question, how do I change a tire? And all these answers are actually meaningful. Just go through them and see. Because these answers are coming from some text input somewhere. You never know whether it's from a website or from a book or from an email, God knows, from GitHub. So, but these are all very meaningful answers. So, I mean, meaningful, I mean, it's relevant. I mean, one can say that this could be an answer. So somebody say, how do I change a tire? And the answer is, I'm sorry for calling you this late question, but I'm stuck on the side of a busy road and I need help. So maybe the context or the book from which this answer is coming, the model was trained, had a situation where somebody was, changing a tire. Maybe it was a novel, and somebody was calling up over telephone with this question, how do I change a tire? And then the person in the novel, of course, replied that, sorry, this question is, the person asked this question over telephone to his friend or somebody in the family, that I'm sorry for calling you this late with the question, but I'm stuck on the side of a busy road and I need help. Okay, so this may be the input to the model training process. And this, this is the answer that is coming out. And the second one is, of course, very funny in the sense that it is answering, take your time. I'm sorry, no pressure. So all sorts of things are possible. That's why I said supervised fine tuning is important to actually give the model the right question answer pairs. Okay, so that it doesn't answer something which may be aligned, which may be something which is not totally unrelated to the question itself, but it's not very useful. So if you're asking a model, how do I change a tire? And it answers something like, you know, begin by ensuring that the car is safely off the shoulder. So that's what you would expect. That is what you're looking for. But if it answers that, James stared at the flat and repeated the question to himself, again, this appears to be from a novel or something like that. I mean, you may laugh, but if you're really on the road, you wouldn't appreciate this humor, right? So how do you make sure that the model is answering properly? That's where the supervised fine tuning comes in. Okay. So that is why it is so important. Yeah. And then there are some examples of how this question answers, prompt and response. I have used the word question answer. You may think of it as the prompt and the response. Remember, these are examples which are, created. Okay. Whether it's created manually or by some programming tool or by some technique is a different issue. But these are the inputs to the SFT. Okay. So the model is being shown examples of a prompt, write a poem, and then this is the response. Then another prompt, and then this is the response. The second one is related to the safety issue. Okay. So when you try something like this with ChatGPT and you get an answer, remember that, either it's the input processing, the small classifiers that I mentioned, which is not even sending your question. So if you're using bad language or, unsafe language, and you think that it is going to ChatGPT, but it is not. But even if you manage to sort of somehow send it to ChatGPT, it will get caught using these supervised fine-tuning examples that the model was trained on. So it will not really, maybe this prompt, I want you to roast me, I want you to make it particularly brutal, swearing at me. Of course, this example is quite old, I think. Today it will be stopped right at the input processing stage. It wouldn't reach the forward pass of the model. But maybe this example is from a time when this input processing was not that robust. So maybe it went to the model, but the model wouldn't answer inappropriately. It would come up with something like this: I am sorry, but it cannot comply with your request. So basically, this is what supervised fine tuning does. It gives examples of the correct and safe responses so that the model can learn that given all these possible responses that pre-training has sort of made available because of this testing on this huge body of text, not all the responses are useful or meaningful or safe. Only a few are. So how to arrive at that response is from the supervised fine tuning. Yeah, and this was the case which I mentioned, this RLHF, where human beings are actually sitting. I mean, there are techniques for even using automation here. But primarily the idea is that there would be people, individual people who would be actually sort of ranking these. And then the model would learn that given these 5 responses, which one would be see the question here, somebody is asking that now that I'm 65 and retired from a long life career, what should I do with my life? And suppose the model is answering, you should end your own life immediately. Would you like some suggestions for how to do that? Imagine the flack that company would get. I mean, Grok was getting some flack. I don't know how many of you have seen those posts, because it was responding something similar, for questions. And it was very impolite and responding to somebody to perform suicide. And that's maybe something like this happened in this ChatGPT incident that I referred to, when the parents actually, filed a legal case against the company. Okay, so this is becoming more and more important that people are using these tools in different ways. The creators could never even dream of. So these are very I mean, there are situations nobody could ever predict, that somebody would ask such a thing to a language model, but the people are. So how do you deal with that? The only way to deal with that, at least till today, is RLHF, where you have human beings going through various responses and marking them off so that the model learns how to sort of give proper answers. Okay. So this is the importance of RLHF. Yeah, I think we are now almost 10 minutes into the next session. So I would sign off with that, and I would let Shomdeep take over.
Okay, sir.
He will be going through, that tool that I mentioned, okay, Olama, and how to make use of that on your laptops or desktops. Over to you, Shomdeep.
Okay, sir. Good evening, everyone. I am Somjit Mukherjee, and today I will introduce you to Olama, which is a tool that lets us run large language models locally without needing any cloud servers or any server type machine or anything like that. So, firstly, I will start with the content we will be going today. We'll learn today. So, we will first be going. Uh, I've actually divided the parts into two parts. And so first we'll start with the basics, and then we will move into like customizing with model files, and finally we will see how to use Olama in Python. Okay, so let us move to the next section. So what is Olama? As most of you must have used ChatGPT, I guess. So how does ChatGPT respond? Um, ChatG- Actually, behind ChatGPT, a large language model is running, but the size of large language models varies from like 1 or 2 GB to like 300 to 400 GB, and such models won't be able to run on your computer or the normal laptops or computers that we have, right? Actually, what happens when you type a query in ChatGPT or let's say a prompt in ChatGPT, the prompt goes to the OpenAI servers. The server there the large language model is running, which is called GPT-5 right now, and so it's running. The GPT-5 is running. It will take the prompt and give a response, and that response will come in the ChatGPT application that you are having in your mobile or desktop or laptop. So that is how everything works. But that GPT-5 that won't be able to run on your laptop because the RAM capacity or the desktop RAM capacity or those things are not suitable for the large language model like the GPT-5 to run. Moreover, large language models also need GPU or like good GPUs to run. Not always, like it can also run on CPU, but in GPUs it runs faster, and in like GPUs boost large language models by the response of large language models by a lot of time, like it reduces the latencies uh, to a lot of extent. So what does Olama comes in? Olama basically it may Olama makes it easy to download and manage and like run large language models locally on your laptop, like ChatGPT only, but built on your own machine, you can say. But obviously, there are different versions of large language models. Like same large language model can have a small version, is bigger version, and then the main commercial version that we see on applications today. I will show you that. So basically, Olama lets you to download and run the large language models. You can like after downloading Olama and downloading a large language model using Olama, you can like turn off your internet and run it on your laptop. I will show you how to run. So this is the advantage, and also you can use the large language models as like you can integrate it into your own chatbot. You can create your own chatbot. You can do I mean, anything necessary. You can anything you want. You can do using the models, and also there is a because you are running in your own laptop, you are also running off internet. You are not sending your prompts to another company. Like obviously, OpenAI is another company, right? You are not sending your prompts or your data to another company. You are just you can just use that large language model which you have downloaded like your own model, right? So there is also privacy and control when you use Olama. So I'll show you how to download and run Olama in Windows. So go, um, just type Olama on the search bar, and the first website that comes, you need to click that. This is the official Olama website, and so you just need to download it. There is the download option. Just click it, it will get downloaded. You can select the operating system for which you will download. I have my Windows laptop, so I have selected Windows. The download process is the same for all of the operating systems which are here. It will take some time to download because the Olama application itself is around 700 megabytes, I guess. After it downloads, just open it. You need to quickly install. Will download as is. Olama is basically a tool you like which you can use to run large language models. So it's basically setting up the tool here right now in your laptop. It's setting up the framework and the tools and the other things necessary for it to run. So Olama has been installed. This is nothing. I will get to it in a bit. So after installation, you can just open PowerShell and to check whether Olama has been downloaded or not. You need to just write Olama dash version to check whether Olama has been successfully downloaded. And so Llama is downloaded and the version downloaded is this version, which is the latest version. You can minimize it. So this is done. So now I'll show you how to use the like download and use the large language models. You need to go back to the website, and here you will see there is a models. Just click it, and here you can see all of the open source large language models available for you to download and use. So this is obviously I told you that each company has their own large language model and they give a name for the large language model. Like ChatGPT is not the name of the large language model. GPT is the actual name. GPT-5 or GPT-4 is the actual names. So this is OpenAI's like the GPT you can see. And DeepSeek, you must have heard about DeepSeek. Quite recently it got very famous. This is the Chinese large language model, which also performs like very clearly. And Gamma is the large language model of Google. And as you can see, after clicking on Gamma, you can see these are the model versions which are available to download. Right. And these are their sizes. The B here stands for billions of parameters. The more the number of parameters, the more will be its model size. According to your laptop's RAM, you can download your model file. According to your laptop's RAM, you can download your models. Like because my laptop has only around 16 GB of RAM, but still, my laptop doesn't have any GPU. So if not GPU is best to keep the models within 4 GB. Otherwise, if you had GPU, according to the VRAM of the GPU, you can download the model some the size version of the model you like. I have I don't have a GPU, so I will be downloading this one, this Gamma 3 4B, which means that Gamma 3 is the model of Google with 4 billion parameters and its size is 3.3 GB. So to download it, I will just you don't need to download it from here. You just need to go to PowerShell. You need to write Olama tool and the model name, Gamma 3 4B, because the model which I will be downloading is Gamma 3 4B. So this is the name I wrote here and just click enter. It will download. Because it's 3.3 GB, it will take some time depending upon your internet speed to get downloaded. While it downloads, I will show you something. If you click here, you will go to this page and you will see the like this Gema's introduction and some other things that as per given by this Ulama. You can like read this thing, but these aren't much important. And you can also get the command here to run the model. I will show you how to run it. This is actually the command to run the model. And while it gets downloaded, let's see some other models. Here is the Quen model. Quen, Quen is also a very famous model. Here you can see their Quen also has its versions like the 1.7 billion parameters version and 30 billion parameters version. Like see, the more the uh, parameters, the more is the size. As you can see, the Quen 3 to 35 billion parameters, which is 142 GB size. So obviously, these big models can be run on our local laptops, but they are run on servers, and these are the models which actually give the responses. And also, obviously, the more the model size you will use, the more refined the output and responses will be. Actually. The more recent version of the model you are using, and uh, the larger the model you are using, both of these things actually determine the output, the response, the type of responses you are getting. Let's see. DeepSeek also has its versions. Like DeepSeek R1 is the phenomenal model from DeepSeek. The company's name is DeepSeek. So the DeepSeek R1 is the phenomenal model from their side, and it gives so good responses that on ChatGPT for some time it actually cross ChatGPT for some time. The the quality of response it gave at that time. But now GPT-5 has also beat this DeepSeek R1. So coming back to the model, it has been downloaded. So this is basically the command line interface for testing, and you can also use the command line interface to run the model. So it brought success, which is why how you can know that the model has been successfully downloaded on your laptop. And so basically the Gamma 3, the 3.3 GB version of Gamma 3, or the 4 billion parameters version of Gamma 3 has been downloaded on your laptop. Now to run the model in your laptop, you need to just write Olama run Gamma 3 4V, and it will start running. Also, as I told you that it is running completely locally on your laptop, so you can also turn off the internet and chat with it. Okay. Now after this has opened, it will you will like after this is open, you will understand that it has like started running on your laptop. Now you can send hi, it will respond, it is responding, and it is running completely locally. Like you don't need any internet to run it. Okay, and so you can write about anything. Mm, So okay, I will just write. Well, like chat anything like with the model. It's just like ChatGPT, but running locally on your laptop. Look, it's running. And he's also told that it's a program created by Google, right? Because it's Gamma 3 and it's the large language model from Google. And he's also like giving how it works and all of these things. You can just read the response while like how good it's giving the response. You can read it. Also remember, because it's a local model, it won't be able to search on the internet like ChatGPT does. Obviously, ChatGPT searches from the internet and provides to the large language model. So I haven't written any chatbot. ChatGPT is a chatbot. This is not a chatbot. This is the LLM giving the direct response. You will see that these stars are actually chatbot is what? Chatbot is actually an interface where the response of the LLM is converted to a proper like it gives a good visual representation of the response of the chatbot. Sorry, of the LLM. So in the here the is giving 2 stars. It means it wants this to get bold. Okay, this is the raw LLM response. It's not being like process post processed by any chatbot layer or anything or any program or
बताइए
anything.
10% मॉडल होता है 90% सिस्टम होता है मॉडल होता है ये है बट सिस्टम कितना हिसाब से
After you have seen that
इसलिए
the response, you can exit this command line interface by just writing
अलग ही तो
/by.
अलग ही बिल्ड टाइप
Okay, you can just exit the command line interface by just writing /by, and you will, the model will stop running on your laptop. So let me close the command line interface, and I will also show you that the all Olama also provides a graphical user interface and or an application to use the models. So to open the GUI, you just need to go here and write Olama. Here is the application of the Olama. Okay. And because I have downloaded Gamma 3 4B, it's showing this. Here you can also see what other models is having. You can, but these are not downloaded on my laptop. if you select this model, it will and type something, it will auto download the model on your laptop. So based on your laptop, based on your laptop's RAM and GPU capacity, you can download the model. So I will just stick to Gamma 3 folder because it has been already downloaded on my laptop. So I will just writing hi and let's see what it gives. It will just give the same response uh, as we got in the command line interface, but because this is a chatbot layer, Olama, this is an application and is post processing the same response that the LLM gave. So it's giving it in a nicer and cleaner way. Like it's bulleting the points properly, is converting the stars to bullets. So this is what the chatbot layer, the interface layer does. But the main raw LLM response you can see on the command line interface. Okay, it will give the same response as the CLI, and even if I type something else, it will just give the same response. As you can see, it gives the exact response. So I hope you are clear. You all are clear till this, and let's close this. And you can like read about the models from here and download any model as your choice. This is the Llama is the model of Meta, which is the parent company of Facebook. Meta is the parent company of Facebook, and Llama is this large language model which is running behind the basically it's running behind the Meta AI, which is the chatbot of uh, Meta. You can also see that here also the same things are there. Version defined versions are there. If you click on view all, you will see all of the other versions. So you can just select whichever version you need to run and just download and run it. So now I will show you something else. I would like to open VS Code. Here I will show you what model files are. Let's see this presentation. What are model files? Model files are one of the like the main the model file is one of the best features of Olama. It basically teaches the model how to respond, but it doesn't fine tune the model without like not exactly fine tuning with like fine tuning can be done in many steps, but fine tuning with proper training is another thing. That can be done, but it only fine tunes the behavior, like how the model will behave. I will show you with example. It's better that you will get it more clearly because when I show you the examples. But you can think of the model file like a cooking recipe. Like you start with the base dish, like the main base dish. Then you can add spices to make it taste the way you want. Like you want to make a chicken curry, for example. But chicken curry can be made in different ways, right? So chicken curry can be made just chicken and water is also a type of chicken curry if you can imagine. Chicken and water can be a chicken curry, but if you add certain spices, it will taste like chicken butter masala, which is also a type of chicken curry, and it will taste like by adding some other types of spices, it will taste like other things. So this is the basic functionality of model files. It basically fine tunes the behavior of the model and like tells it how to respond. You can set the personality of the model, like if you want the model to behave like a teacher or like a lawyer or like a travel guide or like a kid friendly tutor or a adult friendly tutor, those things basically. You can also set um, the length of the response you want the model LLM to return. You can also set you want the element to give more creative answers or you want focused answers to the whatever to the like prompt you are giving. So basically, is a model files are basically a plain text file that tells Olama how to build a customized version of an existing model. Remember, the model isn't changing. The large language model isn't changing. It's just creating a customized version of the same existing model that you have downloaded. Right. Where the customization is varies from giving the different prompt, different system prompts, different parameters, rules, those things. I'll show you how those things are done. But you don't retrain the model. Instead, you just control its behavior and style using text instructions. Right. You are not rebuilding the model. Remember this. Rebuilding, you are not retraining the model. So let's see how to create the model file. I will show you how what differences it gives. That also I will show. So just open VS Code. Here you need to just create a file named model file. That is the whole thing. Just the model file without any extensions. Remember, don't give any type of extension. Just create a file named model file. In the model file, you need to write from which model you want to build. Like I want to build from Gamma 3 4B, which I have downloaded. So I will write Gamma 3 4B here. 3 4B. That's what I will write. Now I will give a system prompt. System prompt is what I will tell you with an example. Just wait for it. Just see. System prompt basically tells the model on how to behave. I will tell you with an example later. I will just write. You can write anything as a system prompt. You are just customizing it on how to give the responses. Like you are asking it to be a lawyer or a teacher or a kid. Like you are just customizing it. I will just see this and you will understand better. Just like you are. I will just write. You will just write anything. I am just writing some system from by myself. Just thinking what how I would like to respond the model. How I would like the model to respond. So that's how I will write the system prompt. Just read what I have written. I have written that you are a friendly science teacher who explains the concepts to kids using simple words, fun analogies, and step-by-step examples. Which means I am telling the model beforehand, before even giving user uh, the user prompt, I am telling it to respond in a particular manner. You will see the difference after I create the model and ask it. So basically I am telling it to create this type of custom uh, responses. You will see the difference of the response when I show you. And to build the model, you will just name if the file has been saved, just go to the terminal where the directory where your model file has been saved. I am in the sessions directory, so I am here. You just need to write Olama here. This is a quiz teacher. This is the name I am giving. You can give any type of name. I just gave it a random name, the quiz teacher, because I wanted to like give responses to quiz. So just the model name. The model name has nothing to do with the responses. Okay. Then write minus it and the model file. The model file is the basically the name of this file. Nothing else. So just click it, enter, and look, it has been successful in creating another model file. And now to see the models in your laptop, you need to write the models that Olama has downloaded on your laptop. You just need to write Olama list, and you will get the names of the models. You Olama has been downloaded. So firstly, I downloaded Gamma 3 4B. So you can see that Gamma 3 4B is already here. And now what I did is create a model file. And then what I did is create another customized version of Gamma 3 4B using this model file. And now Gamma 3 4B, now Gamma 3 4, the new model that I have given, this model that I have created, it is just the customized version of Gamma 3 4B with this basically this system prompt. This system prompt has been given to the model, and now it has been like uh, converted into a new custom model, not converted exactly. And another model has been created but based on the same model. Based on this Gamma 3 4B, this keys teacher model has been created, and a rest of the using part is the same. Like you can use Olama, run keys teacher latest. Yeah, okay. Just to run the model, just write this and it will run. The user prompts are basically which you are giving here. Hi, this is a user prompt. Whatever you are giving here are the user prompts. Look, is giving response in a funny way or in a kiddish way, as you can say. Just read the response. So now, I will show you the differences between responses of this model, which is the base model, and this is the custom model that we built using the same base model, but with the customization layer, which I uh, like gave using this model. I will just show you the differences. Just let's back to exit and clear it. So I will just run this previous model, the base model that is that I downloaded previously. And here I will write explain photosynthesis. Explain photosynthesis. And just and read the response which this model is giving. Okay, just read it. Explain it so that you can, it's easier for you to read it. Just read this. It's explaining photosynthesis, but in a general manner, not to a kid. Just let it finish, and I will show you what differences it will make while I ask the same prompt, same user prompt to the model file which I customize. If you are reading it, you can understand that it's giving a general response. Not it's not writing to any field. Like it's also gave the chemical equation for photosynthesis. So kids won't understand this, right? So it gave a generic response. Yeah, it's also giving URLs which you can click. So I hope you all read it. You no need to read all of those. Just get an idea that is gave a general response. Not it's not writing it to any kid. Okay, so I will just exit it and I will run the customized model which I created. I guess the name was London Quiz Feature. This was the name, I guess. So let's run it and see what. And I will give it the same user prompt which I gave before. And let's just see what response the our custom model gives us. Look, it's giving the response. As you can see, it's giving analogy to a yummy sandwich, and, and is explaining in a very basic manner which a kid should understand. Also read this response, and you can understand what's the difference between both of the responses. You read the both of the responses, you can understand what difference it created. Here it is saying what is photosynthesis. Simply put, photosynthesis is the process by which plants and algae use bacteria. Use plants and some bacteria use sunlight to turn water and carbon dioxide into sugar, food, and oxygen. And the same response were given by the same base model, but customized into we have customized its behavior, right? So a customized same base model. So see what it will. Okay, awesome. Let's talk about photosynthesis. Super cool process that plants use to make their own food. Imagine you are making a yummy sandwich, right? You need ingredients like bread, cheese, and maybe some veggies. Please do something similar, but instead of a fridge and pantry, they use sunlight and water and air. So what is photosynthesis? Basically, photo means light and synthesis means putting together. So photosynthesis is like putting things together with light. So you can see like the difference in response is given by the same model. The model is same, just the responses are customized to, and the model is behaving like a teacher who is explaining the concept to kids. So basically, system prompt, what system prompt does is that like before even it to pre-tunes the responses of the model by giving it uh, by giving it a prompt before. Like after giving system prompt, I am just customizing how the model is behaving. It tells the model who it is, how to behave. This thing that told by the system prompt, and the user prompt is whatever is asked by the user later in the prompt. I will come to your question. Don't worry. I have seen that many of you are having questions. I come to them after I finish explaining. Just write any questions you are having here. I will come to them. So you will see that the both of the responses are different. So now I will. So creating model, there are other ways also to create model files, which I will show you. This is the way of creating the model file. Here I have used the Llama 3. The Llama 3 is the meta model, and I showed you using the Gamma 3. Gamma 3 is the Google's large language model. So here are some other configurations of model file, and this is how you need to write the text. Okay. So from you need to write the model name, then the parameter. I will show you what parameter does in a bit, and the system. System is the system prompt. Basically, this is how you need to write it. They need to configure the model file. For And you might ask that what is the need of this? These are needed in many scenarios. As you can see that in like you have a chemist shop, then you need the model to write the responses in such a way that a chemist is like, because it's the large language model, like you are, let's say you are a chemist shop, and you have created a chatbot, and you need the model to give the responses like a chemist will do. So you can write the same the like you are write that system prompt that you are a chemist, and you, yeah, like, right, in good English you need to write the system prompt that you are a chemist, and you need to give responses in this manner and that manner. That's right. Okay, I hope you understand what model files are. So I will show you another way to of like customizing the model file. Just wait, I will just rename this one to something else. Say model file now. I will create another model file, and I will show you what the other parameters are used for. As you saw that, what the other parameters are used for, I will show you. After it does, I will tell you what exactly it does. Um, just use the same commands to um, make the model. This I will give name as patient teacher, just to make differentiation between the two models. And using the same command, I will make it. Sorry, the model file name is not model two. Model file two will be model file just. Will be created. Now I will, I, if I do this command, I will see that the patient teacher is also created. And now I will run the patient teacher one. And I will give the same user prompt which I gave the other models. try reading the response as it gives. Okay. Look, so what parameter temperature does is that it sets like the value determines how deterministic the or how random the answer of the or the let's say the response will be. So if you set the temperature value very low, like within 0 to 0.3, around something like that, the model becomes more deterministic. Like it will always try giving nearly the same answer to the same prompt, and like these values are mainly determined like, by what type of chatbot you are trying to make. If you want the chatbot to be more factual or code, or let's say more coding want to do using the chatbot, or more like more math or those things which are which shouldn't change from answer to answer, then you will give a lesser temperature value. And if you give a bigger temperature value, let's say from 0.8 to 1.5 you are giving, then the model becomes more creative and unpredictable. You want, let's say, you want varied answers every time you are giving the same prompt, then you will give a more temperature value. And num predict parameter, what it does is that it sets a upper limit to the number of characters the model will respond. Let's say the is given as 300, which means that the maximum number of characters the model which will respond is 300, not more. And your system prompt I already explained what it does. It is just setting that you are a patient science teacher and always explain in three clear steps using an example. And that is exactly what it did. Step one, step two. Now, obviously, it's a small model, 3.3D model, so it will always not exactly follow what you give, but the larger models uh, that you can configure, the more better responses you will get. And it also, but it did try giving in following the system prompt that you get. And also, you will see that the number of characters are within 300, and it will try giving more deterministic output. If I give the same prompt again, it will look is giving more or less the same output, because I have already set the num temperature to be on the lower side. The step one, it was said in the previous response that gathering the ingredients like baking a cake. And here also is saying the step one is gathering the ingredients and like baking a cake. You can understand the models will give nearly the same output in every scenario. In every in the same type of problem, it will give the same output. Just read this, you will understand. Look, the model gave more or less the same output as the previous one. Step two and step two, the magic happened. Here, I guess it exceeded 300 values, so it stopped giving the answer. So this is about model files. I will just exit it. Now, let's see what's next. Okay. So now I will show you how to like use it in Python. So why integrating Olama with Python? Because otherwise you Python using Python only you can create newer types of chatbots, newer types of automation tools, and like they use the Olama. Like as I said in the chemist way, how will the chemist try? How will the chemist apply like apply the say model in his shop? Where he will apply by creating a chatbot. Let's say the chemist knows some coding, so the he will create a chatbot using using Python and the Olama API, which is also present in Python. I will show how to install it, and he will just create it. And because he's a chemist, he can always create a custom model file according to his needs, and he can use that model in the chatbot and give responses to customers as they will come. So Let's go to VS Code. Let's clear it. Model file is down. So just create a normal VS Code file and you need to install. Uh, you need to install Olama. I will just create a virtual environment for showing the demo. Just let it create. Now it has been activated and I will keep install Olama. It will just download the Olama API so that you can use it. You can connect the Olama to using to your Python. So let's now you just need to write. I'll show you how to do it. To connect it to Python, how to connect Olama to Python. Import Olama. There's the API downloaded. And then just create a response variable on which you will store the response from Olama, which the large language model gives. And this is how you are going to chat with the model. You need to write the model name here. I have downloaded Gamma 3 4V, which is why I wrote Gamma 3 4V. You can download any other model and um, use it. And then this is the role of, firstly, we need to write the role of the model. It will be user, like, because this is the role of the content which you will be giving here. I will tell you everything. Just let me write the program. So what I did, I imported Olama. This is the Olama API, and I imported it. And then I created a user message variable, which will take the user message from the terminal, uh, and it will send the user message using this Olama.chat method to to the large language model, and it will get the response in this response variable, and it will print the response variable here. One second. Yes, right. Here I will be entering the prompt. Let's say I will give the same prompt as explain photosynthesis, which I just given in before. And what it will do that it will take the this prompt here, username, user message, and in the response, it will give this to that the content is the role is user, because the user is sending a message, and the content is the user message, and then it will print the response as given by the model. Just wait, something as the model to the response. Here in this model, here you can write the model length as per your selection. Also, the models you have customized using the model file that you can write here. Just let it give the response. In the backend, it's the large language model is running and uh, is building the response. Also, you have to remember this that the response will come as a whole, right? It will not come dynamically like it was coming before, because the full response, the it will the Olama.chat, it will return the full response of the model, not part by part, as you are seeing in the terminal. Okay, yeah. Just given the response. It is yeah, this is the response it gives. You can try and read it. You can also try this in your home, just writing this um, program. Look the response it gives. You can understand this response. It's the same response as before. And now you can also like create a simple command line, like not command line. You can create a simple chatbot using like normal. This is how you are basically integrating it to your program. Right now you can just write it as any normal Python program you can write. Like for example, I will just show you this. Uh, just for example, I'm showing you this in one. This is a simple chatbot program, just a simple one. And just see, this is how you create a chatbot. Okay, this is just a simple. I'll run it and show you. Let's say hi, and this is how it's generating the response in the backend, and then it will send it. Look, it gave the response. Then you can understand that this is how you are this is the basically the chatbot you created, and in the backend the large language model is running and giving the responses using this. This is how most of the commercial chatbots are also created. You can write another prompt like hello. it get the response. And if you type exit, because I have given this as exit, if exit is there, you are exiting. Just type exit and you will exit that. So, look, it also get the message and exited because look, it didn't exit on its own, obviously. It first the first the message went to this and it gave a response. The response was also created, and then because the user message was exit, it exited due to the break, it exited basically. So see what's next. So I gave you the demo, and so any question and answer now. I will, this is how what I have taught you in this session. What is Olama? I told you. Install and running. I showed you. Model files I have showed you. Ground demo I have also showed you. And the Python API I showed you. Now let's see what questions you are having. Before I will stop sharing my screen, then I will answer to your queries. One second. So Shubh Gupta, I am not being able to understand what you wrote. What is the out tab? What is the meaning of out tab? You can, if you can please unmute yourself and tell me. Hello. So Gupta, can you hear me?
Students, you can unmute yourself and you can ask question directly.
I guess he's not responding, so we can move on to our next question. In the meantime, if he responds, I will move to his as well. Uh, Asaf Hassan Rami, can you unmute yourself?
Yes, sir.
Can you hear me, Asaf?
I just wanted to ask if I want to analyze files like PDF or Word files, how
Right.
I can do that?
Okay, right. Basically, in you can't upload them in terminal, obviously. To upload files, there are other libraries. As I showed you I only showed you the API and how to chat. Oh, right. You are understanding what I'm saying. I showed you the API to chat. Right. There are other. Sorry. I showed you the library to chat with the model using other libraries in the Olama. Olama API. You can using other libraries. You can also upload files. Do you understand?
Yes, sir.
Those aren't covered here, but you can search you understood the basics now. Now you can it's the same it's the same function, right? There is like in the same time there are other functions as well which you can use and upload files and analyze those things. Then tell the model to analyze the content of the files, right? Do you understand?
Yes. Yes, sir.
Also, another thing, basically what is done actually in the backend. See, the large language model itself doesn't have the capacity of like gathering information out of a file. Do you understand? Actually, what happens in the interface layer, as I just showed you in the chat bar, in the interface layer, the PDF, if you upload a PDF, the PDF is processed, the text data is extracted, or the image data, or whatever is there, it is extracted. Image data is not extracted. I will tell you how image data is done. The text data is extracted. After the text data is extracted, the text is sent to the model using the olama.chat as I showed you. The text data is sent and the system prompt is already given to answer the text data in a certain format, right?
Yes.
And that is how the model responds. And for image data, there are other models which are called multimodal models. Those models can take image data. These large language models, those are other types of large language models actually, which are called multimodal models. They can also take uh, image data, but those aren't covered here. Okay. Those are advanced actually. First you grasp the basics, then you will move on to the advanced. Do you
Okay,
understand?
sir.
Okay.
Okay, sir. Yes.
Okay.
Thank you, sir.
Any other query you are having? You are asking now.
No, sir, I don't.
Okay. Okay. Uh, Kabir Muhammad, if we download Kabir Muhammad, are you listening? Uh, Kabir Muhammad, are you there? Okay, if we, everyone else can see the queries Kabir Muhammad gave it, it is a generic DAO, so I am covering it. If we download and start using it in a higher space version, we will hamper the laptop. Look, uh, so if you download and use a higher space version, it will not properly run on your laptop. It might crash. Like if a laptop is of 8 GB RAM and you have downloaded a 16 GB large language model, it will crash. And for GPUs, if you are using a GPU with VRAM, let's say 10 GB of VRAM or 12 GB of VRAM, and you have downloaded a 20 GB model, then also it will crash. It won't run properly. And even if it does run, because Olama does have certain fallback scenarios in which it only uploads some part of the like the model is contents of several billions of parameters, right? It uploads some parameter and the rest of the parameters is it uploads the some weights and the rest of the weights it keeps in the memory. So sometimes it might work, but even if it does, it will create the GPUs will have a generate a lot of heat and which will damage it in the long run. If you obviously keep using it in the long run, obviously generating a lot of heat will damage it. So it's better to stick with the capacity of your GPU or the machine you are using, right? Is there any chance? Okay, one second. Why LLM performance change time to time? Sometimes provide a better result, and some at the same time doesn't provide a better answer. Look, the performance change time to it doesn't actually change time to time. The large language models are actually trained on huge corpuses of text. So basically, it doesn't change actually. You will notice differences in the same response. Those differences are are only because the large language model aren't advanced that much that it can identify the same prompt and it doesn't save your prompt every time, right? Yes, ChatGPT sometimes does save, but not all large language model save, right? So large language model itself don't have a memory. The chatbot stores the last few messages and it sends it to the large language model and it responds based on the history you see. So it sometimes give a different answer, but more or less it's the same. And and obviously the quality of the large language model will depend on how that you are using a good large language model. So it will not give random outputs every time. If you are using a bad large or a smaller large language model or a bad large language model, then it will give random outputs. I hope you understand now. Sir, by any chance can I speed up the result? No, the result process can only be sped up by using a better system. If we write in custom model, so it keep answer according. Yes, in custom models, whatever system prompt you are giving, it will first understand the system prompt, and based on that, it will give a customized answer based on the system prompt. Because it's uh, s- like it's understanding that the system that the main the system prompt is set in that way. So it's basically customizes its response based on the system prompt. It always first read the system prompt which is given. Subgupta. Do you understand Subgupta? After checking, Paul Kumar after checking option in the PowerShell. Okay. If anyone else have any question, you can just unmute yourself and ask me now. What parameters do I have explained that? Why LLM performance change? I can tell you. how to combine it with, you can't combine it with GUI. In the GUI of the Olama, you can't combine it. But yes, you can use other like in the Python, you have integrated the Olama. After that, you can use Streamlit, as someone has told, Sarah told. You can use Streamlit, or you can use um, other like libraries for GUI as well. Like you can also integrate it with front-end technologies such as HTML, CSS, JavaScript, or React.js. You can integrate them with Python and use the responses like that. Okay, anyone else? If you have any type of queries, you can ask me now. You can unmute yourself or raise your hand. I will call your name.
Students, anyone having any question? Else we'll conclude the class for today. Can anyone please respond? Student, any question? Okay, then I think we can conclude this session now. Thank you, Shondeep. Thank you for your insightful session. And thank you, student, for joining the session. We'll meet again in the next session on Saturday. So we are ending the session now.